right. Chapter 2-7, we're going to talk about translations and reflections on a coordinate plane. And a coordinate plane is just simply your X and your Y axis. Okay, it's a grid pattern that you can graph coordinate points on. Just as a review from yesterday, because I kept mispronouncing it and saying it wrong. It's a coordinate plane. You have coordinate points, but it's divided into 4 quadrants. So again, this is just a review, but if you would on your papers, I would go ahead and label each quadrant on your notes. So this is quadrant 1. This is quadrant 2, and get used to Roman numerals because that's the way you'll see it on any kind of quiz test or even like an iReady, something like that. This is quadrant 3 down here. And this is quadrant 4, and in Roman numerals, a V means 5, and 1 less than 5 is 4. So that's the Roman numeral for 4. So you've got quadrant 1, 2, 3, and 4 in a counterclockwise rotation around the coordinate plane. All right. So for today, we're going to talk about translations and reflections. So underneath translations, I want you to put the word slide. And under reflection, I want you to put the word flip, because that's what the two, that they're different. And that's basically what the two are. So if you think about, if you have a shape, all right, so if we have, say, a rectangle like my cell phone, okay? If you have a shape and I say you do a translation, you take it, you don't twist it, you don't move it, you don't do anything, you just simply slide it up to a different area of the coordinate plane. So it doesn't turn, it doesn't get it doesn't get smaller, bigger, anything. It just simply slides to a different spot. A reflection, you have what's called a reflection point or an axis of symmetry. And what that means is you've got basically, it's like a mirror. And so you've got this shape. And when you take this shape and you flip it across the axis, you actually, you flip it this way. So you rotate it. Now with a rectangle, it doesn't show up as much, but it'll show up here in some of these other shapes. So a translation, it doesn't spin, it doesn't twist, it doesn't change shape. It just simply slides like you were just taking a building block and sliding it to another part of the coordinate plane. A reflection is actually, if you guys ever, hopefully you did it in like grade school, where you took a piece of paper and you folded it in half and you opened it back up and you put ink or something on one side and then you folded it back over and opened it back up and you had that reflection image. So you should have whatever you put on the right side, when you close that paper and then you open it back up, the ink is supposed to transfer onto the other side and then you've got that mirror image. Did you guys ever do that? Okay, thank you. So that's what a reflection is. And you can reflect, and you have to really be careful on your instructions on especially reflections, because you can reflect over the x-axis, which is this right here, right? And so if you reflect over the x-axis, you're going to mirror down, or you're going to mirror up across that x-axis. If you mirror across the y-axis, which is right here, you're going to mirror this way. You're going to flip-flop left to right. So you really have to watch in your instructions on this little unit, on this section, because your reflection is going to matter whether you're reflecting across the x-axis or the y-axis. Okay, sound good so far? All right, not too bad. All right, so this first example here that you have in your notes, it says find the coordinates of the vertices. Vertices is a very fancy term for these points right here. See them? M-N-O-P. Okay, those are your vertices. Those are your corners, if you will. Okay, so find the coordinates of the vertices of the image of figure M-N-O-P. You always name a figure by its corner points, vertices points, translated 6 units to the left and 3 units down. So the first thing I want to do is I want to show you what that translation is going to look like on this graph. And then we're going to talk about how you can even get these new points without doing the graphing. Okay, so if you take the point M, okay, let's do this in colors here. If we take the point M, and here is the point M right there at 1, 0. okay? If we want to shift that, or slide that, I should say, 6 units to the left, that's backwards, right? 6 units to the left and 3 units down. So that means if we put our pointer, and I'm going to put the arrow here, just so the circle. If you put your pointer right on M, right on that point, and then you count 6 spaces backwards, 1, 2, 3, 4, 5, 6, and then you go down 3, 1, 2, 3, your new point sits right here, okay? And that is now the point M1 because it's M, but it's M being translated. Okay. Now I'm going to do the same thing with N. I'm going to take N from the point N right here, and I'm going to go backwards 6. 1, 2, 3, 4, 5, 6, and down 1, 2, 3. And there is my new N point, and we'll call that N1. And then we're going to do the same thing with O. Okay, we're going to go backwards 1, 2, 3, 4, 5, 6, down 1, 2, 3. And we're going to put our new O right there. And that's our O1. And then we're going to do last, we're going to do P. So we're going to take P and go backwards 6, 1, 2, 3, 4, 5, 6, down 1, 2. We're off our graph, but that's okay. And that is the point P1. Okay. Now, you'll notice now if I were to connect all of these, okay, they should look exactly like what we moved. All we did was it slid backwards 6 and down 3. The whole image shifted backwards 6 and down 3. Now, if you want to, because you have to, in the instructions, right, it says find the coordinates. That means the X, Y, the points. Find the coordinates of this new image. Well, you can do it one of 2 ways, and it doesn't matter to me. You can either do what I just did, and you can actually do the translation, draw your new shape, and then you can name all of those points. So I'm going to go through and I'm going to name M1, right? This is my new M, so it's M1. And my new M1, well, you got to look and see where that new blue point is. It's at -5, -3, right? Backwards 1, 2, 3, 4, 5, down 1, 2, 3. So my new M is at -5, -3. My new N, you always do them in order. My new N, which is N1. Well, let's look and see where that purple end point is, our new end point. We went backwards 1, 2, 3, down 1. So -3, -1. That's our new N. Our new O point is at -1, 2, and then down 1, 2, 3, 4. So -2, -4 is our new vertices for our new translated image. And then, is that right? -2, I'm looking at it crooked. Yep. And then our new P, which is P1, is at -1, 2, 3. So our X value is -3. And then down 1, 2, 3, 4, 5, 6. So down 6 or -6. The other way you can do it, okay, is before you start, okay, if you don't want to draw this second image, and sometimes you're going to actually have to graph it, but in this case, it doesn't say you have to graph your new image. So there is a way to do it without graphing it. And that is if you take all of the points for your original image, right? So your original M was, and let's look at our original M. It was 1, 0, right? 1, 0. Now, I know from my information here, I'm going to circle it in red. I went 6 units to the left and 3 units down. That means my new M, okay, is going to go 6 units backwards. And this is where, if you're comfortable with adding and subtracting integers, you can do this without actually graphing anything. Because if you had for your X value, remember your left and right movement is your X, right? If your original X was a 1 and you went negative or to the left 6 units, what does 1 minus 6 equal? Cam? -5. So my new X is -5. Now look at your old Y value. Your old Y value was 0. And 3 units down is -3, right? -6 is 6 units to the left because that's backwards. 3 units down is -3. So if I was at 0 for my y and I go down -3, what's my new y value? Somebody that hadn't answered. I'm gonna try to make everybody talk. 0 minus 3. Yes. -3. Now you'll notice, right? Here is my m, my new m, my m1 when I did it graphically. Here is my m1 when I do it mathematically. You still get the same value for your m. It's just, are you more comfortable visually, actually doing the translation visually on the coordinate plane and then naming the new point, or can you do it mathematically? Looking ahead at your homework and the quizzes and tests, I would say that you should always have a coordinate plane with you or in front of you so that you can do it with the coordinate plane, but I still want you to know how to do it mathematically just in case you come across a problem that just gives you 4 points and then gives you a move and then says, what are your new points? And you're not given a graph, right? You're not given anything. So we need to be able to do this mathematically as well. So let's look at our original n. So I'll do original here in black. Our original n was what? Our original n was over 1, 2, 3, up 2. So our original n was +3, +2. That's the coordinate point of -n. Now I know that for my x value, I need to do -6. Oops, I should do that in red. I know for my move for my x value, it's -6 because it's to the left. And I know for my y value, it was a -3 move because we went 3 down. So my new n, my n1 would be 3 minus 6. -3, and then 2 minus 3. Go ahead. -1. And again, look at my n value here that I got when I did it mathematically, and look at my n value over here when I did it by doing the translation on the graph. Both processes work, okay? If you have a graph and you're more comfortable with it, do it with the graph. If you possibly don't have a graph, and you need to do it mathematically, you need to be able to see how to do that as well, okay? Let's go ahead and do this number 2 here. So I'm going to erase all of this, and we're going to do number 2, we're going to do it mathematically, okay? Just to kind of get a practice on both. We did one full problem by doing it on the graph. Now let's do one full problem doing it mathematically. All right, so I'm going to erase just this so that I have some room to work here. All right, so it says here in number 2, find the coordinates of the vertices of the image for MNOP. Okay, that's this original image right here. Okay, translated 4 units to the left. So what number would I assign to that? No, -4 units to the left. How would I write that as a operation? Bella? -4, yeah. -4, because left is always backwards, right? Negative. And then 4 units up. How would I write that as a mathematical operation? Yes. +4. So my x's, right? Remember my units to the left, that's my x's. My x's are going to go -4. My units up, anything up and down is always going to affect your y. So the first thing I have to do is I'm going to come over here to the right and I'm going to identify all my original points. So my original m, we've already done this, but we'll go ahead and write it again. My original m was 1, 0. My original n was 3, 2. My original o is 1, 2, 3, 4, -1, is 4, -1. Okay, that's my original o. And my original p is 1, 2, 3, 1, 2, 3, is +3, -3. Okay, those are my original points. Now for my translation, I need to get a new m. So I'm going to take my m here. This is my new m. Whoops. My m1. Now my x value, and if you need scratch piece of paper, because sometimes these can take a little bit of extra work, okay? My m was 1, 0. So I'm going to give myself some scratch paper here. Here we go. My m was 1, 0. And I know that I'm going to go -4 on my x, and I'm going to go +4 on my y. So my new x, what's 1 minus 4? Somebody that hasn't answered yet this morning. What's 1 minus 4? Yes. -3. Good. And what's 0 plus 4? 4. All right. So my new coordinate for my M is -3, 4. Okay. And I got that by subtracting 4 from every X and from adding 4 to the Y. So now I'm going to do that same thing with my N, and my new N is going to be N1. And I'm going to erase because I'm very limited. You guys get an extra sheet of paper and staple it, okay? Because you do have to show your work, and these require quite a bit of paper, okay? So for my N was 3, 2. And I know I'm going to go -4 on my X because that's my left movement. And I know I'm going to go +4 on my Y. So somebody that hasn't answered yet this morning, what's 3 minus 4? -1. And 2 plus 4. Yes, ma'am. 6. Oops. So there is my new coordinate point is -1, 6. So for my N, -1, 6 is my new coordinate point. For O, I'm going to do the same thing. I'm going to take my O, which is 4, -1. And I'm going to subtract 4 from every X, right? Because I'm moving 4 units to the left. And I'm adding 4 to my Y's because I'm going 4 up. So what's somebody that hasn't answered yet? 4 minus 4? 0. And -1 plus 4. -1 plus 4. +3. Good. So my new point is 0, 3. And then last, I've got my point P1. Sorry, I forgot that on my O. My P1, and I'll do it right underneath this one since I have room. I'm going to go a -4 on my X and a +4 on my Y. That takes care of my -4 units to the left and my up 4 units. So the last one is 3 minus 4. Zach, what's 3 minus 4? -1 and -3 plus 4. Who haven't I heard from? Logan. What's -3 plus 4? 1. So my new point is -1, 1. So that's a good example of the number 1 of how to do it by graphing the new image and then writing out what the new points are, the new vertices are. The second is a good example of how to do it mathematically. Yes. Yeah. Yeah. You need to show me for each point, you need to show me this, how you got your new point. Okay. How you got your new point. Yes.
You have to write that outside the graph like the end.
You need to, well, you need to have what your originals are. Yeah. At some point, you're going to have to name what your originals are if you're going to subtract to get your new ones. Yep. All right. And I know these are a lot of work, which is why your whole worksheet, I think, is 5 problems. So there's not a lot of them because they do require quite a bit of work. All right. So now we're going to see, let's see. I don't think I want to do translations again. Find the coordinates of the vertices. Okay, we're not going to do this. I'm going to skip 3 as far as notes because it's exactly like 1. So 3 units to the right would be +3. You can go ahead and just jot this down. We're not going to do the whole problem. 3 units to the right, that's a +3 on your X. 1 unit up is a +1 for your Y. And it wants you to actually, well, it doesn't even say you have to graph it, so you can find it whichever way you want. But that's another example of a translation. So I'm not going to do another example of that. Okay. Now I want to do an example of a reflection. So let's look at number 5. Okay, the vertices of figure WXYZ are, and then they list them. Okay, so we got to graph them all. So first we're going to graph W. So W is at +2, +3. So everybody go ahead and graph +2, +3 and name it W. And then you're going to graph X, which is at +4, +2 and name that one X. And then you've got a Y, which is at 3, -3. So +3, -3. And that is your Y. And then last you have a Z at 1, -1. And that's your Z. Okay, and then go ahead, connect your points here. There's your image. Okay, we've graphed our original image. Okay. Now it says graph the figure and its image after a reflection over the y-axis. All right, so first you got to notice that it is the y-axis that we are reflecting over. And if it helps you, I would do this on your homework. Once you identify which one you're reflecting over, give yourself a reminder, okay? Just give yourself, this is called an axis of symmetry or a reflection point, meaning that our image is now going to flip over that y-axis, okay? So there's a way to do it. We're going to do it with the image, and then we're also going to do it. I'll show you how to do it without looking at the image. So if we're reflecting over the y, I want you to look at the point W. No matter what, or let me, how do I want to say this? When I flip that W over this reflection point, it's going to flip and be exactly the same amount of space away from the reflection point on the left and the right. Does that make sense? So if I am, I wish I had a pointer here. Let's do this right here. If I am 1, 2 spots to the right of my reflection point, or of my reflection line, or my axis of symmetry, that means that W is going to reflect 2 spots on the other side of my axis of symmetry. So 1, 2. Okay. And because this is a direct reflection, the height is not going to change. Does that make sense? So my X is going to reflect and go from being, what's this W here? What did we say it was? 2, 3. Okay. My W is going to go from being 2, 3. Now it's going to be -2, 3. Notice the X values, the sign flipped, right? The sign went the opposite, but my Y value did not change because this image doesn't move up and down. It just simply reflects over the axis. So that means my X value, which was originally 4, 2, is going to reflect to -4, 2. Okay, the X is going to turn negative. The Y is going to stay the same. So we're going to put a point at -4, 2. Now we're going to look at our Y value, and our original Y value was 3, -3. And because I'm reflecting over that Y, my Y is not going to change. My X is going to turn -3. My Y is going to stay -3. So my new point is -3, -3. And last we have Z, and Z was 1, -1. So when I reflect it, remember when you're reflecting over the Y, your Y doesn't change. So only my X. So this is going to change to -1, -1. And then when I plot -1, -1, I get this. And now when I connect all of those, it should look exactly like my other image on the other side, only mirrored. And so if I was to fold this graph along that red dotted line, or my axis of symmetry, if I was to fold my paper over that axis of symmetry, these 2 images should lay right over the top of each other. Okay, make sense? The other thing I want to show you, and we're not going to do a full-on example of it, I just want to show you this, and I'm going to take, I'll just use this, I'll use this graph right here because, well, that's in Y. I just want a blank graph, but that's okay. I'll use this one. Just pretend that old City Hall and new City Hall hidden on there. I just want to show you something. If we are reflecting over the X-axis, right? If we are reflecting over the X-axis, I just want you to see how it'll look a little bit different. This is our X-axis, okay? And if we have an image, and we'll just put one right here, I'll do a triangle so it'll be quick. If I have, this triangle right here, okay, and I want to reflect it over the X-axis, now what's going to stay the same? Noah? Yeah, all my X's are going to stay the same. Because I'm reflecting over the X-axis, every single X is going to stay the same. So this point is, and I know that's what you were saying, so you're right, Noah. So this point is 0, 1, 2, 3, 4, 5. This point is 0, 5. When I reflect it, now my X isn't going to change. Now it's my Y that changes. And so my point is down here at 0, -5. Okay. This point right here is negative 1, 2, 3, 4, 1, 2, 3, 4. This point right here is the point negative 4, 4. When I reflect it over the x-axis, my x is not going to change, but my y flips this time. And so I would be at negative 4, which would be right here. And then for my last point, this point is negative 3, 2, right? Negative 3, 2 is this point. When I reflect it, notice that my x doesn't change, right? My x doesn't change. My y flips. And I would be at negative 3, negative 2, which would be right here. Whoops, I did something wrong on my graph. I did 4, 4 wrong. Sorry. One, 2, 3, 4, 1, 2, 3. There we go. That's better. Sorry, I graphed negative 4, negative 4 wrong. That new city hall got in my way. And if I connect all of these, you can see that if I were to fold it in half now along this line, my images would reflect up and down. So if you want to write it out, if words help you, okay, if you're reflecting over the y, oops, your y stays. If you're reflecting over the x, your x stays. And then the other one, it'll change its sign. Okay? Sound good? All right, for those of you at home, click load, show all of your work. If you need to add an extra page, you can click the plus sign at the bottom and you can add an extra page to show more work, and email me if you have any questions.